In this video, continuation of the video titled Spatial Coordinates Edge View of a Plane, we're going to use that same question, and now we're going to find the true shape of that lamina. So we had our lamina ABC. Now we're going to have a look at how we find the true shape of that surface. So at nowhere in the question at the moment do we know the true length of any one of the sides, so here we're going to have to try find that piece of information. So this is a continuation of the previous question, so you need to have set up the question from the previous video. The link is in the description. So just a quick recap on what we did here. We needed to first find an edge view of the surface, which we need to do here also. And to find our edge view, we drew a horizontal line on the surface of our lamina, starting at point A, and it's horizontal in the elevation. In the plan, that same line is going to be through a true length as it is horizontal in the elevation. So starting at point A, as it started at point A up here, I'm going to take find where the horizontal line intersects the line BC. That intersects it here and gives me a true length. And then I'm going to look along that line to find a point view of the line, which ended up here. So that is a point view of that line, the height of which was found by taking the height from the elevation out here. So this height here is equal to this height. The height up for C is the same altitude that C is at down here, as is B. B is this height above the XY line. B is the same height above the XY line here. The next part that I need to do is to find the true shape of this object. So to find the true shape of something, I'm now going to look in perpendicular to it. So if I have an edge view of that surface, so if I have an edge view of the surface here, and then I'm able to look in perpendicular to it, I will then see a true shape of it. So I would be looking straight down on top and seeing the true shape of that solid, or the lamina in this case. So what I need to do is I'm going to project each of my points out perpendicular to the line to the edge view. So it has to go perpendicular to the edge view, and I'm going to project the lines C, A, and B out. So out along here are the point B is going to be out here somewhere, A here somewhere, and C on this line. As this is a second auxiliary view, I'm going to follow my rule for measuring where I'm taking my distances from. So I'm working in this one, I'm skipping this view, so I'm going to measure from this view. So just before I move on, I'm going to put an x2, y2 line out here. So I'll be measuring from my x2, y2 line out along here. Now what I can do is I'm going to be measuring from my x1, y1 line back. So I'm going to measure the distance from here back along. So to do that, I can take my compass with my xy line and measure the distance from the x1, y1 line back to C. Mark that same point on line C over here, and this gives me the location of C. I can do the same thing for B. So from the x1, y1 line back to B, mark that out here on the line coming from B, from the xy line, or x2, y2 line, and this gives me point B. Point A, again, is done the same way. So I'm going to be measuring the distance from the x1, y1 line back to A, and on my xy line, I'm going off the screen, this is point A. So I measure the distance from my x2, x1, y1 line back to A, that distance here, mark that same distance out over here. So this is A. If I join the three of these together, this gives me the true shape of the lamina ABC. So this here is the true shape of the lamina ABC. If space is an issue on my page, what I can do just to reduce this down a little bit is I can put in a measuring line. So a measuring line is exactly what it sounds like. I would put in, instead of measuring from x1, y1, I might put in a measuring line here and call it measuring line. And when I'm measuring, instead of measuring point C from the x1, y1 line, I'd measure it from here. So point C would have ended up on the x2, y2 line. B would have been slightly above it, and A would only have been this distance above the x2, y2 line. That's a perfectly valid way of doing it. So I'd have point C here, B here, and point A would be up here somewhere. I still end up with the same shape, it's just a little bit closer to the x2, y2 line. I'd essentially have gotten rid of this much material, so gotten rid of all that part of it down there. So just a quick recap. After we find our edge view of the surface, going to look in perpendicular to that and put in an x2, y2 line. I'm going to measure all my distances from the x1, y1 line or my measuring line back into the plan and mark those distances out here, giving me my edge view, giving me my true shape.